Even at the hobbyist level, the use of technology to build parts for a custom subwoofer enclosure or other car audio items is becoming more and more obtainable. I'm currently working on building an underseat subwoofer enclosure for 4 10-inch subwoofers, and I need to add some beauty panels to the box to give it a unique look. Now, in the past here on the channel, I've shown how to make a lot of these shapes using specialized woodworking tools, but in this video, I want to focus more on using technology. We'll be going through the process of making parts on a laser along with a CNC router. Now, real quick, before we get into this, I do want to thank our monthly channel sponsor, Crutchfield. Cars themselves are becoming much more technologically advanced, so it can be difficult to know what parts we need when we're adding an aftermarket car audio system in order to interface with the vehicle correctly. On the Crutchfield website, we can enter the year, make, and model of the vehicle, and if Crutchfield has researched your vehicle, we can see exactly what parts and harnesses are needed for head unit upgrades, installing new speakers, and more. Crutchfield also has excellent US-based customer service, so if you have any issues along the way, you always have somebody that you can call up and talk to. If you guys want to learn more about them and take advantage of a special offer for car audio fabrication fans, you can check out the link here on screen or down in the video description. Here we have it, guys. I just wanted to give you a quick refresher on our design here and the beauty panels that we're going to be adding in this video. So you can see that we have these panels over here on the side of the enclosure, and this is just to match the vehicle DNA of the truck. These shapes right here are similar to the floor pieces in the truck. We'll be making these shapes on the CNC router and then transferring them to our final pieces. And we'll also be making these shapes here. I'm going to be making the shape for this insert here on the CNC router. And then I'm also going to be making the shape for the outside part of this insert that goes around. This part that you see here is going to be permanently attached to the enclosure, and then the insert will insert down inside of it. That allows me to save body filler rather than using body filler to come around the outside here and make this chamfer. I'll be making it out of wood. What we're going to be starting off with making though is these pieces on the inside here. These are acrylic pieces that I'm going to be using to have all the different sponsor names highlighted right here in the middle of the box. The piece on the inside is going to have this brushed aluminum look, and then I also have this trim piece around the outside that I'll be making out of black acrylic just to add a little bit more unique design there in the middle and around the outside. So the first thing I do in my modeling program is I take each of these different shapes and I isolate their piece, and then I create a sketch that just has the outside geometry of these pieces. On some of these pieces, like this one here, I've modeled all this detail work with the chamfers and then the bull nose bit that I'm going to be using on the router to cut these different shapes, but I don't need to export that information because I'm going to be doing all of that manually. So for this piece, for example, when I go to export its geometry, I'm really only looking to capture the outside edge and that inside edge of the cutout. But let's go back to focusing on our acrylic piece here. I'm going to export that and I'm going to bring it into another program. So the other program that I've loaded these into now is Adobe Illustrator, and you want to use a vector design program, a graphic design type program for this because we're going to be using the laser. If you're familiar with running a laser machine, that's the type of program that you're generally going to be using to create these different profiles. You can see here I have the first part that I'm going to be cutting, and this is really as simple as just the two different shapes. I've got the inside path there and the outside path. So I'll be exporting this all by itself as an SVG file, and that's the type of file that the laser can read and it knows to make these different cuts. And then the other file that I've created in the meantime, this is going to be just for that insert that has that brushed aluminum look. And you can see I've added the different sponsor logos along with my own logo here. What's important here is you'll notice that each of the logos is filled in. And the reason that's important is it allows our software here to tell the laser cutting software that we want each of those logos to be a fill, which allows them to be engraved rather than cut out. As an example here, if we were to turn off the fill on my logo here and we were to add a stroke, then the laser cutting program is going to think that it needs to cut this out of the acrylic. But that's not what we want to do. We want to leave this without a stroke and we want it to have the fill. So if we go back to our first shape, which is that outside piece, we only have strokes applied here because that piece only has cuts it doesn't have anything engraved. So I've exported that as an SVG, and now here we are in the laser cutting software, and I need to tell this software exactly what I want it to do. And for a laser machine, there are several different parameters we can control. The main ones that we want to pay attention to are our speed and our power. Now in this case, since I'm going to be doing a cut, I have the laser set to full power, but there are applications where maybe you just want to score a line, or maybe you're cutting something extremely thin like cardboard, and in that case you might not need full power. But for this 1/8 inch acrylic, in my case, I do need full power, so I've got that turned on. And if we were doing an even thicker piece of acrylic, it might not cut all the way through on the first pass. We might need to add additional passes, so we could do that here. And the other parameter we can control is our speed. Obviously, if we're moving very fast, we might not cut all the way down through the material. So in this case, I have my speed set. And remember, this is going to change based on different thicknesses of material and even different manufacturers and different colors of material. All of that is going to change our parameters. So sometimes you need to do a little bit of a test cut. I've done several test cuts and I cut black acrylic quite often. So I have this set as a preset for my machine, the black acrylic 1/8 inch thick. There's my settings. So we should be good to go. I've got a piece of this material rough cut, so I'm gonna load it into the laser and we're gonna start cutting it. This is my 1/8 inch black acrylic that I'm now cutting for that outside trim piece. So now we can cut out our sponsor panel. Much like before, we have cut settings, and this material is only a 1/16 of an inch thick, which means I don't need to have full power in this case, and we can use a slower speed. For the engraving settings, we once again see speed as a parameter. In this case, I have that maxed out, and then we have the power of the engrave. We don't want to use very much power because we just need to burn through that top layer of material to expose the black material underneath. And another thing for engraving is you're going to see lines per inch. The more lines per inch you have, the more resolution you're going to have to the engrave, but the longer it's going to take to actually engrave that part. All right, let's hit the start button, and we're gonna get this engraving underway. A little bit loud with the ventilation fans going, but the logos are starting to take shape. Now, depending on the laser machine you have, more advanced lasers will do this a lot more quickly. In this case here, a little bit slower on this one, but definitely making progress. And now that the engraving is done, the laser is making its cutting pass to cut that outside profile. And once we remove all that protective paper, check it out, there is our logo insert ready for the rest of the enclosure. So now we can turn our attention to CNC cutting these wood pieces. And first I'm going to focus on exporting the shape for these side pieces here. I have this main part and then these additional little side details. Now the other pieces that we need to CNC cut are going to be this middle insert and then that outer piece that it's going to insert down into. But the problem is these pieces are actually larger than what my CNC machine can handle. So for that reason, what I've done is I made a second modified version that you can see these are cut in half. That's going to allow me to cut just half of the shape on the CNC machine, and then I can use that half shape to transfer to a full piece. So once again, I will create sketches of the outside edges of these pieces, and let's take it over to our CNC software. So here's the software for our CNC router. Now you can see I've brought in the shape that is for the side of the box along with that detailed piece. And for a CNC router, here is a couple of different important parameters to pay attention to. So first of all, for our cut, we can tell the CNC machine, do we only want to cut halfway down into the material? I've already told the software that our total thickness is 1/4 of an inch, but maybe we don't want to cut all the way through. Maybe we're just doing some sort of pocketing on the piece, but that's not the case here. We want to cut all the way through, so I've maxed out that depth of cut. Now this is super, super important. You want to make sure that you don't forget this. We can also tell the software, do we want to cut on the path that we've designed, or do we want to cut inside the path, or do we want to cut outside of the path? In this case, since we're cutting our shape, we want to cut on the outside of the path. But an example of wanting to cut on the inside of the path is, imagine there was a circle or a hole on the inside here. We'd want to tell the software to cut inside of that to have an accurate shape. Now you'll notice these yellow areas here. What these yellow areas are that I can move, these are called tabs. Some CNC routers are in the $100,000 plus range, and they have a really nice vacuum table that holds our work surface down to the table. So in that case, we don't have to worry about tabs. But for our application here, we're going to be holding our workpiece in place with either clamps or template tape. And we want to make sure that as we are cutting the piece, we don't want this inside overhead piece to break free. So what the tabs are is the router bit will come along and it will actually lift up a small amount of distance. It will go across and then go back down and keep cutting. And that's going to leave a tab which will lock this piece in place. Those tabs are so thin, it's very easy once we are done making the cuts to trim those tabs away. I'll show you guys that in a little bit. So we've got those two shapes here, and then we also have these shapes that I've made. These are those half pieces for the insert and for the outer trim. You can see that there are a ton of tabs on those as well because I really want to make sure that I hold these thin pieces nice in place as I'm making the cut. So we're ready to move on to the next step here, and that's our speeds and feeds of our cutting. So similar to the laser where we're controlling the speed and the power of the laser, in this case on the router, what we can control is the feed rate. And yes, I know for those of you guys that have more advanced CNC machines, you can also control, the speed of the spindle. In our application here, we really don't have a lot of control over that through the programming here. We really just control our feed rate. So this is how fast the router is going to be moving around as it cuts in inches per minute. The plunge rate is how fast the router is going to come down into the material as it starts making its cut. And then the depth per pass is how far the bit is going to come down in each step as it steps through the material. So if we have a 1/4 inch thick piece of material that we're cutting and each pass is only a 1/16 of an inch, then it's going to take 4 cuts to completely cut through that material. So changing these settings is where you're able to optimize how fast you can make these pieces. We could of course say, okay, maybe 40 inches per minute is too slow. We know we can cut 60 inches per minute, so we could change that factor. And let's say that we know that we can cut deeper into the material. Let's go a full 1/8 of an inch on each pass. That way it's only 2 different passes. And then we can simulate this programming here, and we can actually run through. So this is real-time speed right now. Let's go like 8 times speed. We can see the path that the cutting head is going to follow, and we can see that our total cut time is only 6 minutes. All right guys, so we're back in the shop now. Now we can start using the CNC router to start cutting out these different shapes that I'm going to be using to transfer to my final shapes on the box. This is my CNC router that we're going to be using, and I first need to prepare my workpiece here by sticking some template tape to the back of the piece. That's what's going to hold this in place while it's machined. Next, I stick my raw piece of material in place on the CNC bed. So now we can start programming this cut. First of all, I have to tell the CNC machine the exact thickness of my piece of material. That way it doesn't go any further than fully cutting through the piece. Next, we confirm our piece is in fact clamped and held in position, and we confirm the bit that we're going to be using to cut. So now we need to tell the machine exactly where the top of our surface of material is. So I'm going to jog the CNC over the center of our part, and I've plugged in this little probe. So what we've done here is we have a clamp that connects to the bit collet, and that way the machine will know when there's continuity between this bit touching off on this pad here. And we also tell the software how thick this pad is, so it knows to do the math to subtract that thickness in order to determine how far it is from the bit to the top of this board. So we'll start the probing operation there, and it's gonna go down very slowly until it makes connection, and then it lifts back up. Now obviously the more fancy CNC routers that are much more expensive have a far more advanced way of doing things like this, but if this is your first exposure to CNC routing, I just wanted to show you guys this stuff so that you understand some of the different information that the machine needs to know in order to start running. The final parameter we need to tell the machine is our XY 0 point, in other words, this bottom left corner. We need to jog the center of the router over to that position and then tell the machine when it's in that position. We can now attach our dust collection shoe, we can turn the spindle on and start our machining. So I just took this off the CNC machine, and you guys can see those tabs that I was telling you guys about earlier that keeps this piece locked in place. What I can do is I can just cut these carefully with a razor blade. And now over here on the router, I have a spiral flush trim bit adjusted so that the bearings are going to ride against this surface, but the bit is going to cut away those little tabs on the bottom. So now I have these shapes made and ready to be transferred to our final pieces of wood. Let's get the other larger shapes cut. So you can see those shapes cutting here on screen, and once I copy that half shape over and mirror it, I will have my full shapes along with all of the other pieces. Now we're not done yet though, we still have some more analog details that we need to add to these pieces before we add them to the box, and we're going to be covering that in the next video. Next time you're working on a car audio build and you need assistance with getting the right parts, don't forget to check out show sponsor Crutchfield. You can learn more and get a special offer for car audio fabrication fans at the link down in the video description. A big thanks to them, along with Anthony, Mike, Mo, Jerry, Marcos, William, and the rest of the Patreon membership team. A big thanks to all those guys for making these videos possible, and as always, thank you guys for tuning in and watching.